Okay, welcome everyone. I think we're going to get started with this Munch and Learn on Kubernetes 101. This is going to be a two-part presentation. The first part will be recorded and we'll play a video from that recording. And the second part will be live doing a hands-on lab. So I'd like to welcome first our live speakers today. With me is Nigel Poulton. And Nigel will be part of the recording that we have done back in June for Discover, and will be also with us for the hands-on parts. So, and Tom Phelan is our other speaker, but Tom is only part of the recording. So let me, before I start the video, let me just give you a quick, a few housekeeping items about Munch and Learn. First of all, this is our 8th Munch and Learn. It's a monthly program that we started with the HPE Dev team back in January, and we had every month we had a new session. You can watch the replay of the previous session on our campaign Munch and Learn webpage here. You can also see the new topics that we'll be covering. For September, you'll see on the page that we didn't advertise it yet because we still have a draft title, but we don't have everything completely decided. But the topic will be on digital transformation and on data analytics workload with Matt McCaw from HPE. I'll come up with the registration link in the coming weeks or coming days, sorry. So that's for our next session. The other thing about Munch and Learn, if you remember, we called it Munch and Learn because we'd like to share the munchies or the munchies that you're having wherever you are on the planet. So, and to make this fun, you can share that on either Twitter, on our Slack workspace. Yeah, thanks, Nigel. And you can share with us what you're having while listening to this session. So again, if you want to join our Slack channel, you can join it by going to slack.hpdev.io. And then we have a dedicated Munch and Learn channel for dumping those pictures that I copied here. So as I said, we have two parts in this workshop. The first part is a video that we will be playing with 3 speakers, myself introducing the subject, and Nigel and Tom discussing about Kubernetes and container orchestration. And the second part, so bear with us for the video. You can, of course, ask questions. We have subject matter experts with us in the room here as with Don. He's with us today, and he will be helping us answering questions. So you can ask questions during the video. We will also run a little poll during the video so we can know each other a little bit better. And finally, we'll go into the hands-on part for those who are interested. And the hands-on part will be done through a set of Jupyter notebooks that we have built, and that will be using to go through the different steps on managing a Kubernetes cluster and deploying an application, scaling an application, and so on. We'll go into the details of that in 30 minutes from now. If you want to continue and join the program, there are several ways you can do that. If you are into QR code, you can scan that and we'll give you, this will take you to a web page with all the links to the different ways you can join the program. Otherwise, our main web page is developer.hpe.com or hpedev.io, and you can also take a look there. Everything is hanging off that page. All right, so with this, give me just 1 second for sharing a different thing here. Welcome everyone to this Kubernetes 101 workshop. My name is Didier Lally. I'm a distinguished technologist with HPE. I'm also a tech lead for the HPE Dev community, and as such, one of my roles is to create exciting content for our community. That's why it's a great pleasure for me to introduce our 2 speakers for the first part of our session today. Our first speaker is Nigel Poulton. Nigel is the author of several best-selling Kubernetes and container books. His books and video courses have helped over 1 million people start their journey with containers and Kubernetes. Our second speaker is Tom Phelan. Tom is a fellow at HPE and in the HPE software organization. He's the CTO of Ezmeral software, which includes HPE container platform. And As a side note, I'd like to say that we are using HPE Container Platform to power the hands-on environment of this session. During the next 30 minutes, Tom and Nigel will cover the following topics: why Kubernetes, designing application and infrastructure for Kubernetes, and finally, running application on Kubernetes. In the second part of the session, I will guide you through 60 minutes of hands-on workshop. So please don't leave after the discussion. I have 6 exciting labs on deploying application with Kubernetes that I'd like you to go through. With that, gentlemen, I'd like to hand it out to you for the rest of the session.
Thank you very much, Didier. How are you, Tom?
Thanks, Didier. That's fantastic.
Pretty excited about this session, to be honest. Though I will say, I do think Didier's got the fun stuff at the end, so definitely stick around. And I think for you and I, Tom, the pressure is on for people not to leave while we're having this conversation. But I think it's a pretty good topic, so there should be plenty to get involved with. And speaking of getting involved, actually, we'd love to make this session as interactive as possible. So we'll try and get involved and answer questions where we can. We've also got a bunch of SMEs that are involved in the back end as well, that are there to answer any questions. So we say this quite a lot when we've done stuff in the past with dev lunches and things. It's a super safe space, all right? So if you have a question about something that we're talking about, be brave enough to ask it. Like, don't be afraid. It will make the session way more fun and way more interactive. Anyway, look, on that topic, aside from sticking around to do the labs at the end, Tom, what are we going to talk about today? What are the questions on our minds?
Well, thanks, Nigel. This is great. Let me just reconfirm what Nigel said. There's no bad questions. Please feel free to ask anything you want. This is called Kubernetes 101 for a reason. We'll answer all questions. So in that vein, let's step way back, Nigel. Hey, what is Kubernetes? Kubernetes is this open source project. I know Google pushed it. I know everyone's really excited about it, managing containers. Hey, but can you tell us why should we be excited about Kubernetes?
So I think the first thing to say, Tom, is that containers are here. And the joke or the tagline around that is resistance is futile. Okay. So I think the first thing to take on board is that we can't run away from containers. Okay. Now, the closer that you look at them, we need something to help us once we start deploying to containers. And one of the things that we say quite a lot is, if you had VM sprawl, so you had your traditional applications and you were deploying them to VMs, and you had, let's say, 10 VMs for an application, if you then migrate that application to run on containers, the chances are you might have, and I'm picking a number out of the air here, right? You might have 50 containers in that application. So as you scale things like that, it becomes more and more important to have something to help you there. And look, there are other options out there, but Kubernetes is the outright winner. So in my opinion, look, don't run away from containers. They're here, right? Let's embrace them. As soon as you do that, though, like almost the instant that you do it, you will realize we need some help. And that help comes in the form of Kubernetes. Now, I know that you, Tom, know a thing or two about Kubernetes as well. I'm curious for your take on this.
Sure, Nigel, you're absolutely correct. So the world got used to virtual machines. And virtual machines were fantastic. They allowed us to run applications without interference with other apps. But they came with a cost. They were expensive. They came with additional CPU overhead and storage, networking, and memory. Okay, but then we add these containers. And let's be really serious, Nigel. The concept of containers had been around for a long, long time. But Docker, they made this revolution. They made containers easy to use. So you'll hear things like Docker runtimes and so forth. And then what Kubernetes does, it brings on top of this, it brings orchestration and a common API. So I can run my applications not only on premise. So I got my applications, I'm running them on my hardware in my data center. With that same API, hey, I can also run them on the public cloud. So I can run them on Amazon or Google or Microsoft or somebody else. And I have a common API. What this really does is it takes the burden off the application writer to tune it for these particular solutions. And we'll go through that in the next 30 minutes because there's some really good information about that. But Nigel, that's where I think the differentiation here is in that common API.
you know what, as well, Tom, just in case some of this is buzzwords to some of the audience, okay, an analogy that I use quite a lot when we're talking about Kubernetes as this common API for a modern application is just think of it the way that we used to think about Windows or Linux for a more traditional application. As long as you write your application to run on Windows or Linux, it doesn't matter what the infrastructure is below. That's all abstracted by the operating system. And in the same way, Kubernetes can abstract underlying cloud infrastructure, like you've even said, on-premises infrastructure as well. So when we talk about a common API, that's what we mean. You know, before we flip on to the next section though, Tom, another thing that I think is really important as to why Kubernetes and not something else is the ecosystem that's building up around it. We're going through a phase at the moment where certainly at least two areas, the areas of security and storage, we're starting to see the ecosystem, the third-party ecosystem around Kubernetes just almost explode into life. So if we take, I don't know, let's just take security, okay. There is so much tooling that helps us from a security perspective, growing organically around Kubernetes. Now, yes, we said before there might be some other options other than Kubernetes, but they very much lack the richness of tools and that sort of strong partner ecosystem. Do you see that as well?
Absolutely. And I want to throw out two buzzwords, you know, just like you were saying, Nigel, security. And I'd also say there's this other term called telemetry. Let's just call it logging, the logging and auditing. And you're right, you know, there's an open source project known as Falco. Many of our audience may be familiar with Falco. It's a bolt-on type of thing onto to Kubernetes, which enforces security. And that's becoming more and more critical. All we have to do is look at the news headlines to see how important security is to the high-tech industry. And then there's also a term called Prometheus. And Prometheus is a very common a telemetry or logging toolkit that helps us coalesce logs and look at them and audit them. And so I would encourage our audience, you know, to go out and start to look at these things. It's a way of learning. So you see Kubernetes and you see Falco, you see Prometheus, and you'll start putting the pieces together and you'll build up your understanding.
Well, that's a really good point, actually, Tom. So speaking of the pieces, okay, let's say you as an organization make the decision, yeah, we're going to go down the Kubernetes route. How do we start planning our infrastructure and our applications to take advantage of that?
That's a fantastic question. And obviously we're moving now, just for you following along, we're going to the second bullet item here. We're looking at designing apps and infra. And as Nigel points out, one of the really key portions, I will call it the seminal design factor of Kubernetes is that it's pluggable. So you have a thing called a storage interface, a CNI, a container storage interface, and also another thing called CNI, container network interface. And what that is, that's the first thing you look at when you're saying, okay, I'm going to roll out my Kubernetes cluster, but where do I want to store my data? Do I want to store it on premise? Do I want to put it in an object store? Do I want to put it in a database? But I could always use this CSI. And if I use this CSI API, then I can take my application, bundle it, and deploy it using the API for Kubernetes. And then Kubernetes will actually communicate with my CSI compatible storage. And I can start to move forward. Similarly, with networking CNI, I can plug in. There's a lot of people doing a lot of work. You might hear terms like Canal and Calico and Flannel. These are all types of network underlay, and we don't have to go into the details here because there's all kinds of special things. But what you have to know is that if you need network security, if you need certain packetization, if you need certain performance, you can select a CNI that's probably available out there today and start to use it. And like I say, no one wants to hear me talk, Nigel, so I'll turn it back over to you about more of the infrastructure for Kubernetes.
Yeah, well, just summarizing what you say there. So almost a day zero decision is to say, right, I'm going to need to think about external integrations. You use I think the idea of storage there. Make sure that you are building around storage platforms. They can be cloud-based storage as well, but on-premises solutions as well. that will natively plug into Kubernetes and expose all of their advanced features. Super important to do that. And on the networking front as well, 100% agree. If I could just take it, I don't know, a little bit more high level and say, design your infrastructure with the ability to burst up and down where possible. And if you can, especially if you are deploying into the cloud, design where possible to be able to go multi-cloud. Now, it might sound like a buzzword again, but just like a couple of maybe really simple ways to do that. Well, one of them, okay, is to say, if I am on a particular cloud platform, or we've got a chosen cloud provider at the moment, by layering Kubernetes on there, we talked about before that we can effectively sort of commoditize that cloud infrastructure below. However, if we are leveraging proprietary technologies on somebody's cloud, then the ability to migrate a workload to a different cloud or to spread it across multiple clouds becomes more difficult. So when you're doing your design work, let's say if portability of your workloads is like a must have, then maybe running, and I'm just going to pick something here, MySQL on your Kubernetes cluster versus your cloud provider's native database solution. If you go with MySQL on Kubernetes, doesn't matter what infrastructure is below it, you can take that MySQL with you. Another thing though, Tom, which you just touched on a little bit earlier, was service mesh, okay? Now you may want to say something about service mesh yourself, but something just for those who service mesh may be a buzzword for. I remember years ago, I did a short piece of work for a company. It was indirect. It was for a company that was doing work for a broadcasting company. And I was young at the time, and I went into one of their operations centers where they had a wall full of screens. And I was just like, this is the coolest place I've ever been in the world. And it had all their feeds of all the different channels and things that were going out. And I don't remember much other than them saying, these are our live feeds. This is what we see. This is what the customer sees, all of this. We've got people monitoring it so that if a feed goes down, we don't wait for a customer to pick the phone up and say, hey, the TV show I was watching's gone off. We're more proactive. We're watching this. And I would say that a service mesh, I mean, it does a lot more okay on security and stuff, but it is one of those ways it gives you visibility, especially networking, which you talked about again, Tom, gives you visibility into what's going on in your network, how traffic is flowing, how you can optimize traffic flow. And I really feel that if you don't think about things like that right at the beginning, I don't know, on day two, you'll really hate yourself and kind of wish that you had.
You're spot on there, Nigel. Yeah. So there is SEO, which is the term that very most common term for the service mesh, but as Nigel points out, it's a way to separate clients from servers. So we're running our services on Kubernetes, and we want to have this single place. It's like that wall of screens that Nigel said. And I want to go to that one place, and I want my client to say, oh, I want a database. Find me a database instance. And we do load balancing and HA and disaster recovery and all that in that upfront portion, so that I get routed to an operating version of that database. So it could be the right version, right type, and so forth. And then they say, oh, no, I need more than a database. Now I need a video streaming service, or now I need, maybe it's even an artificial intelligence model that I need to process. And I can take all those and I can squish them together into a pipeline. And then I build up this pipeline, and I can use Istio to look up each of those services. So it's an extremely powerful concept. So Kubernetes is way more than just deploying sets of containers. You'll hear a term called a pod, which is a collection of microservices working together with a common IP address and so forth. But Kubernetes is much more, and as Nigel points out, one of the key points is that service mesh. And now I'd like to say is, okay, we've been talking about some infrastructure. We've talked a little bit about Kubernetes. Now let's kind of put it all together and talk about running applications. So Nigel, how would I take some of this tooling that we've been talking about and deploy an application, real application on Kubernetes?
That's a good question, Tom. So I might start from like a slightly surprising place here. I think one of the first things that you need to do is as an organization, you need to look at the structure of your organization, the way that your teams are built. And I think even taking it down even lower, if you've got to look at your staff, okay, and say, do my staff have the right skills? Do my staff have the right mentality to take on such a thing? So something maybe that we just touched on earlier in that conversation, Tom, was about pipelines and things like that. But what we haven't mentioned yet is we quite often design our applications very differently to work with containers. So if I can just paint like a really big picture, instead of having, I'll oversimplify, right? But a humongous application that does a lot of different things, right? But is bundled as a single, let's just call it a single binary. We don't build applications like that to run them on containers and on Kubernetes because of several challenges. Like if we wanted to scale that application, it was really difficult. You couldn't, let's say it was year end and you need to report the scaling. You need to scale the reporting part, report the scaling part. You need to scale the reporting part of the application. It's really difficult when that application is one entity. So what we've done is we've tended to take applications and all the different things that they do, and we've split out every feature as its own mini application. We call it a microservice. These all talk to each other over the network, over APIs. So the point I'm trying to make here, Tom, is that as an organization and as a team and as an individual, sometimes it's a lot to take on, and you have to be geared up to be able to do that. So you have to pick the right people within your organization that are going to have the right attitude to do that. There's a steep learning curve here, okay? You've got to be able to put in, not better, possibly different support structure within your organization. You probably as well, if it's your first application and your first venture into something like this, you're going to probably pick a team of specialists that are like your, I don't know if outliers is the right term, but they're like your SWAT team for something like this. They will go and deploy the first application. They'll make all the mistakes, okay? Pick the right application as well. Not something line of business critical on day one, okay? Pick something easy, low-hanging fruit, pick the right people and run that in production. Probably take that same team and do it again. And then you start to build like a set of patterns. You start to build pipelines and workflows, then look and document it, start taking it to your wider organization. I mean, there's a ton of other things that I'm happy to talk about as well, but what are your thoughts, Tom?
Yeah, Nigel, you hit, I love it. It's a great topic, and it's so important that we spend time on this in Kubernetes 101. It is how to make your Kubernetes rollout successful. Exactly what you point out. You need to select your team. It's not only about technology, it's about the human factor. And then as you point out, it's really critical in order to make your first application successful, since we always want to make a first impression on our bosses, we got to make sure that this one comes out. So I would suggest that, as you're rolling out and you're deploying this, you select what's called a cloud native application. And as Nigel points out, when we say cloud native, it is an application that's written in what are called microservices, and you might hear them called stateless microservices. But what they are is they are containers from the ground up. And as you point out, they scale well horizontally. So they scale out and they scale back. And those are the easiest things to run on Kubernetes, since Kubernetes is designed for cloud native applications. I'd like to talk in a minute about non-cloud native, because that's where things get really kind of exciting. But let's just focus on your point, is how to make that individual successful with Kubernetes is, bring up the team, select your application, and then what's really important, you need to make sure you have sufficient resources. And that's why people go to the cloud. It's because, hey, they have unlimited hardware and I can expand and contract it. When you're looking at resources on premise, maybe you have an application that has privacy concerns or whatever, but you're not willing to put it out in the public cloud, then you need to do some scoping. How many servers, how many racks, how many top of rack switches, how much storage bandwidth, how much network bandwidth, all that has to be factored in as you set up your platform for your Kubernetes. And that's where true value comes in. Company like HPE, company like others who are specialists in this sort of thing, they can help with that.
So do you know what, on that topic, Tom, as an independent here, I don't work for HPE, so I feel like I can have a a little bit more levity when I say this here. I do feel like choosing the right partners is really critical, and choosing those partners early. So we've talked about the technology side of things. I think we used storage as an example, right? You want to partner with companies that have best of breed storage systems that expose those features into Kubernetes so that they can be consumed by your applications that are running on Kubernetes. But as well, you want an organization, or you want partners, I should say, that will help you when things go wrong, okay? To provide, when you've got a P1 going on and you need somebody to help you, to bounce ideas off, to put specialists on the call with you. Now, I would say, do that as early as possible with those first applications, because the last thing that you want as an individual and as an organization, but I really mean as an individual, right? If you are one of the people responsible for rolling out applications and you don't test the support organization and the support structure behind that until you are quite far down the line and you've got some really important line of business application on there, things go wrong. And now for the first time, you're picking up the red bat phone or whatever, and you're calling your support partner and you find out, oh, wow, we've never done this before. We've never tested it. We don't have the procedures in place. They're maybe not as good as what we had thought. You do not want that at the wrong time. So test all of that stuff, not just your technology staff, not just your staff that you are responsible for, but put your partners to the test as well. And then any tooling as well that you've got in place as soon as possible. It's a buzzword, right? But throw a bit of chaos engineering in there if you can. So start pulling the plug on things and start tipping cans of water on servers. Well, don't do that, but you know what I mean, right? Let's start breaking things and actually find out, how do we respond? What does it look like? Because the chances are, if you are, and we'll talk about these more traditional applications possibly next, Tom, if you want to, but if you are deploying refactored, re-architected applications that are kind of new to you, they probably break in different ways to what you expect. So test and test and test and do it early.
Yeah. Once again, you come up with a fantastic point, Nigel. You have to QA these things. You have to test them because things will break in unexpected ways. I love the term chaos testing. It's kind of this new thing, this new buzzword going around the industry. And it sounds really scary. Oh no, we're going to throw tomatoes at the computer. No, but it's just making sure that we have a well understood set of testing criteria, and then we run all the testing criteria into our process. But I would like to just spend a real quick moment on.
Tom, can I just say, I'm
Sure.
really sorry to cut over you there. But when you're talking about it being scary, I want to hold my hand up and say it probably is a little bit scary. But I think the point that you and I are making is it is so much less scary than testing it for the first time in live when the real chaos is kicking off. So yeah,
True.
probably it is a bit scary. But take the easy scary over the scary.
Absolutely. I didn't mean to mislead people. You're absolutely correct.
Oh, no.
Take the fear that along those lines. It can also help yourself. So we're talking a little bit about legacy applications. So applications that are probably written in Java, they've been running in your enterprise for 20, 25 years. Hey, but you still want to bring those to Kubernetes. And as you point out, Nigel, you can bring a whole lot of refactoring. You can actually rewrite your application. And that is what some people do. It's a somewhat costly, somewhat time-consuming issue. But there are other things. You can make yourself a little bit easier on you by looking at some other technologies. There's open source projects called like Cube Director. So you just go to GitHub and you look it up. And what it is, it's a tool that makes it easier to run a legacy application on Kubernetes. And you say, well, Tom, what does that really mean? Well, if you're running a complex application on Kubernetes, you typically have to write some piece of Go code. Go is the language that the Kubernetes is written in. And you might hear a term operator, or you might even hear a term called custom resource definition, CRD. Fancy terms, but what they are they're little pieces of Go code that help your application run on Kubernetes. And Now we're getting into engineering, we're getting into subject matter expertise around Go language and Kubernetes. If you don't want to write any of that, you can take an open source project like KubeDirector, just create a YAML file, which is pseudo English text, and then give it to KubeDirector, and it will do that magic for you. So it allows you to take a legacy application, not write any Go code, not have to worry about writing your own CRD, but use this KubeDirector, and then you can get the scalability, you can get the resiliency and cost effectiveness of Kubernetes to run your legacy app.
Yeah, I totally agree. On the benefit side of doing that, even though you probably don't get the full benefits of rewriting your application, it's of course a trade-off. It's much simpler to do than refactoring your app. But it gives a lot of organizations, and we've seen this a little bit already, it's an easy stepping stone onto Kubernetes. And like you say, you get a bunch of the good stuff that comes with that. The one that just jumps out to me all the time at the moment is security, and really simple things like vulnerability scanning of images. Once you have containerized and got an application onto Kubernetes, you still get so many of the benefits, even if you haven't refactored that application. And what you can do is you can run with that application for a while, and in the background, you may not even realize it. Your organization and your team and you as an individual are probably learning a bunch of Kubernetes as you go, maybe unintentionally, until you reach the point where you have a body of knowledge within the organization and a body of experience that says, maybe now we're confident enough to actually take a stab at refactoring this. I mean, look, you may never need to, but it may be that you've taken the easy step to get on there. You've got a bunch of the benefits. As you've run with the application, you've organically upskilled, might not even notice that you've done it. And suddenly when you next look at the application, you're like, oh, actually, we're not bad at Kubernetes now. Maybe we can take step 2, 3, 4, and 5.
I love that. On the job training, I call that. You just magically learn as you're playing with that. And there's so many websites out there that will have sample code that will walk step by step to help you put together your first container, use Kubeflow to invoke your first and deploy your first application, and then help you see how all the pieces work together. It is not a daunting task. So, and plus there's plenty of environments out there, plenty of Slack groups and so forth to ask questions and get help. But you're absolutely right, Nigel. Step at a time, you walk in there, you start doing little things, then sooner or later you're ready for the complex work.
Yeah, totally agree, Tom. Absolutely magic. Look, everybody, I really hope you've enjoyed the conversation. I'm going to speak for Tom and we've really enjoyed it for sure. Be sure to stick around though, because the fun stuff is about to happen. So I'm going to hand it over to Didier, and I'll just sign out by saying, look, we're going to try and stick around. We've got the SMEs on the background. Get involved with the questions and stuff, yeah?
We're going to move to the hands-on lab now. So if you read the chat, I was saying that we are going to dump a link in there for you to register for a platform. My advice, if you are really new to the topic, is just to follow along. Thanks, Patrick. To follow along without a platform. It's easier. If you know a little bit more, it's okay. You can register for a platform. We have 50 platforms available, first come, first serve. The way this works is you actually go to that page that we just talked about. So if you go to that web page and you can click register, you put in your email, full name, and company name, check the box and register for the workshop. Once you do that, you'll get a couple of mails. The second one will have information about how to join how to connect with a student ID and a password to our platform. The platform we are talking about is a Jupyter Hub platform that is available on the internet and runs a number of workshops. If you look at the webpage, you will see that we have 20 workshops. We only using one of those, which is called Kubernetes 101. I will give you a few minutes to join. We can monitor how many people actually join by, we have a kind of a dashboard that looks at the number of registration, and so far it's seen only mine, but feel free to join. In the meantime, we can maybe talk about the poll results. And so we've seen that a lot of you are, at least 42% are developers, and we have a fair amount of architects, and that's great. And most of you, 53%, are new to the subject, which is kind of normal for a 101 talk on Kubernetes. And but the fun part is we have 2 people that think that have invented it. So I'm really happy to have those on board. And the other interesting piece is the third question, which is you're not using it, but have plans to. And that's 40%. 24% already have it in production. Interesting as well. So that's for the first poll. We have another one later on about questions on how you expecting to learn and the next steps.
Hey, Didier,
yep.
Those 2 people that pretty much invented Kubernetes, like that really puts the pressure on you and me, doesn't it, when we're answering questions? It's like,
yep.
We can't make it up anymore.
Yeah. So once you get your credential, I don't know if I can monitor this a little bit better and see any activity in there. Not yet. Oh yeah, okay. We've got 15 people that are registered already. That's great. So let me move to so when you open up the notebook with your username and login password, sorry, you end up in a workshop called K8S 101. And there's a README first, which is open by default. And let me explain quickly, if you're not familiar, this is a Jupyter notebook, and this is open source technology. It works on Windows and Linux, by the way. So this is just to make people using Windows also included here. And the way the lab works is that we are going to open a number of notebooks. So these are called notebooks. And the way you run or you use notebooks is always going to be the same. I need to explain for those who have never used a notebook before. A notebook is a series of things called cells. So here, for example, what you see in blue, this notebook is only one big cell. And cells can be either markdown, and this is the case, this is markdown, or it can be code. If it's code, and we'll see that in the next ones, then what type of code that you run is here on the upper right corner. You see here we've got Python 3, and this is the default because Jupyter was invented at the time where Python was big, and initially it was only provided with Python. But since then, more than 60 kernels are available for you to use within a notebook as a code cell. So you will see that in the future, in the next notebooks, we use a lot Bash, because it's pretty easy to run commands. And in Kubernetes, by the way, a lot of the commands are using a tool called kubectl or kubectl, which we'll talk about. And this is a command line tool. So everything that is command line is quite convenient for notebook presentation. So we will use a Bash kernel. And as I said, you have either markdown cells or code cells. When you want to run a markdown cell, all it does is renders it and it goes to the next one, which I'm doing now. When you run a code cell, it executes the code that is in the cell. And you can just use the play button at the top here, or you can say Control-Enter on your keyboard if you're a keyboard guy, or Shift-Enter. And it's important to know the 2 different ones here, because Control-Enter will stay on the same cell. So when we have some cells, a piece of code that we want you to run multiple times until you see something different happening, then you can use Control-Enter, and that's convenient. It stays on the same cell, and you can run multiple times. The output of the code is displayed right below the cell, and when the cell is running, it shows a little asterisk, and then it shows a number, which is the number of times you run that cell. If there is when a cell is running and it shows a little asterisk like that, you cannot run another cell. And there is one example in the lab. You will see that it basically hangs. Let's put it this way. So you have to stop it, force it to stop, and you use the stop button at the top. Okay, that's about it to get started. So let's walk into the introduction. First of all, I would like to say that this training, I didn't build it up. Unlike Nigel, when he writes books, this was taken from the Kubernetes Basic interactive tutorial, which was available on the the Unix or the CNCF platform under Creative Commons license. So this is used under the license. I reused the pictures. All I did was to port this from, they were using Katacoda. It's another technology. And they were also using Minikube, which is a single node Kubernetes for learning. And I ported this to Jupyter notebooks, and my backend is HPE container platform, Ezmeral container platform. That's the only difference. The rest is exactly the same code, the same training. So we have 6 modules, and each module is represented by a notebook. The first one used to be to say we create a Kubernetes cluster. Actually, we don't create it because it's already there. We have it, as I said, in our Ezmeral container platform environment. So we've created it and we are all using the same. It's a little bit different from the Katacoda training, which everybody had his own Minikube cluster. The next, but we'll still see a couple of options on how to start using kubectl to manage your cluster. In module 2, the next module will deploy an application. In module 3, we'll expose the application so you can get to it and see some kind of results. Then we'll explore the application. Then we'll expose the application publicly to actually get something from the application. Then we'll explore some of the scaling option, which is quite a nice feature of Kubernetes. And also we'll see how you update an application doing rolling upgrades and how you can roll back in case of problems. So that's kind of the overall scenario. So let's start with the first part. But maybe before we do that, let me just get our expert here, Nigel, which, by the way, surname on Twitter is Nigel the Borg. Maybe you can first explain the history of Kubernetes and why you picked up that name.
Okay, yeah. So, I think you might have mentioned earlier on, or one of us did, that Kubernetes originally came out of Google. So although containers might be quite a new concept to a lot of us, I think Docker containers have been around for 7 or 8 years or something now. But for years before that, Google was rocking loads of its infrastructure on containers. So like every time you would do a Google search, Google would spin up a container in the background, do the search, give you the results, tear down the container. Gmail, all your Gmail sessions are running containers, stuff like that. And Google needed technology in-house behind the scenes running all of that, yeah? So my phone's turning on because I'm saying Google. I've got an Android phone. But Google needed something to manage all these containers that were constantly being spun up and spun down. And it had an internal project that was called Borg that managed all of its containers. Eventually, they kind of learned lessons from Borg and brought out another project in-house called Omega. But Borg, because of how it was used internally at Google, and Kubernetes is kind of, so like Google had Borg to manage their containers, then Omega, and then they said, hey, why don't we take a bunch of this stuff that we've learned and make it open source? New product, built from the ground up, Kubernetes. Yeah, so Borg, Omega, Kubernetes. So yeah, that's where the kind of reference you'll sometimes see in Kubernetes documentation and conversations and things around Borg. So it was an internal Google project, but it kind of relates to the Star Trek Borg characters as well. We probably don't want to go too much into it, but yeah.
Yeah, I think so. Do you want to, what's your take on how to define best a Kubernetes cluster before we start with that piece?
So this is really interesting, actually, especially as I looked at the poll, right? And I saw that there are a lot of developers on here and hardly any operations people. And it made me think about this cluster side of things, because quite often as an organization, when you decide that you're going to containerize your apps and you're going to deploy to Kubernetes, it's a very much application-centric approach that you take in. And that's probably the right way to do it, right? Because your customers at the end of the day care about applications. You care about delivering features through your applications. However, you must be aware that below your applications, they have to run on something. And in the case of Kubernetes, your containerized applications run on a Kubernetes cluster. And that cluster, if you've never had any experience of building and managing and deploying high performance, highly available clusters, then you may get into trouble running your Kubernetes applications. So the cluster is what your applications run on, and it's comprised of two components, really. A control plane, which is all of the intelligence that implements things like self-healing, rolling updates, rollbacks, things like that, all implemented by the control plane. You want that to be highly available and high performance. The other element to a Kubernetes cluster is the worker nodes, and that's where your user-facing applications run. So if you run Windows-based applications, somebody was asking a question about that earlier, they would run on Windows worker nodes in your Kubernetes cluster. Linux applications would run on Linux worker nodes in your Kubernetes cluster. But it's very important that, I've mentioned high performance and highly available. So if you're building your own, you need to make sure that you are distributing your cluster infrastructure across different availability zones and regions and data centers and things like that. Or alternatively, if you can't or don't have the time and the skill and the resource to be able to build and manage and deploy and keep up to date your own Kubernetes clusters, you can go to a cloud provider. Just about everyone offers them these days, and take an off-the-shelf hosted Kubernetes service for them, where they say, okay, we'll handle all of the control plane stuff. We'll make it highly available and high performance for you for a fee, of course, but we'll take care of all of that kind of legwork. And we'll just present an interface to you to run your applications on. And that's a real easy on-ramp for a lot of organizations, especially that don't have the time or whatever to kind of learn the Kubernetes internals and are just interested in getting the benefits of running their apps on there. So yeah, the cluster is super important, because that's what all of your applications run on. If you don't build it properly, or if it's not high performance enough, then your applications are going to struggle.
Thank you, Nigel. So let's get into the kind of running a little bit of code here. The way this works is that every time we will open a new notebook, we need to kind of say who we are and get a token. So it's just, basically your student ID and your password, which you got from your mail, which we instantiated here automatically. Don't worry so much about the rest for now. We'll explain some of it as we go. Just run that thing, that first cell, to get your environment variable set, and get yourself here a token, a session, basically, to identify against our Kubernetes manager, which in this case is Ezmeral container platform. So that's okay. Don't worry so much about the URL and this for now. The next step we mentioned earlier is that in order to manage Kubernetes, most people would do it through a command line tool called kubectl like that, or sometimes people say kubectl. And so here, typically what you would do if you use the GUI of Ezmeral Container Platform or other management tool, you will download the kubectl, or you would have it and you would download the config file. In this case, we automated all the process so that we have a local file that is copied here, and then we can start running kubectl commands. First one would be kubectl version, which give us kind of a JSON that tells us about minor and major version for the client and the server. We can also run a config current context. So that is also useful if you're managing multiple clusters. You would have different contexts. And here you see that it's the name of a cluster, the name of a tenant, and the name of a user. Okay, great. So let's experiment with a couple of options here. kubectl cluster info will give you some more details. What's the endpoint? What's the port number for the different services running in the cluster? More important, what's my cluster like? If you click here and run that cell and you do the command kubectl get nodes, you'll see that we're actually running a 4-node cluster made of 1 master and 3 workers. And congratulations to the infrastructure team. Patrick is part of it because it's been up for 246 days, which is great.
Hey, Didier, can I just mention, very quickly on that output? Of course, this is a lab environment, and it's credit. It's been up 246 days, so that's impressive. But if we look at it there, this particular cluster that we're on only has a single master. And that means there's only 1 node running the control plane services. What we talked about before, in a production environment, you would want 3 or 5 masters just for high availability, because if that master goes down, then yes, your applications might stay up and probably will, but you won't be able to affect changes to any of the applications or any of the infrastructure. So that's, I guess, that's a really good way of something that we've just talked about there. We're seeing it in the real world now. We've got just a single master that's like a risk if it's production, but then we have 3 worker nodes to run our applications on.
And in our case, these nodes are physical nodes, but they could be VMs. They could be running on the cloud or on the premises. So that's kind of also the interesting things about running Kubernetes. You can build a cluster out of quite a lot of different things. Let's run another command that you can take a look at, which dumps the entire configuration. So you can see a number of things about yourself, about the cluster in the environment. Let's move on to the next module and get some more commands for you to learn. So we're going to deploy an application, and let me see. Do you want to maybe say a few things about what's a deployment, or so they don't have to read all of this stuff?
No. So I think we mentioned earlier that Kubernetes manages containerized applications. So that's just an application that you have written to run in containers instead of virtual machines or whatever. The funny thing is, though, even though Kubernetes manages containerized applications, you can't actually run containers on Kubernetes, or at least you can't run them directly on Kubernetes, right? In order to run a container or a containerized app on Kubernetes, you have to wrap each container inside of something called a pod. And we don't have to go into detail now, but it's just a really thin wrapper that it does a few things, okay, but it basically adds some metadata to your containers that let Kubernetes manage it. But then we take those pods and we further, and we might talk about this in a little bit more detail later, actually, but generally speaking, we'll take those pods, which are the different parts of our application. So we might run some pods for the web serving front end. We might run some pods for the store on the back end that persists the data, some pods for logging, some pods for authentication. All of those work together for an application, yeah? But we would take, let's say, the web front end pods, and we'd wrap them in another Kubernetes construct called a deployment. And we will see this later, I remember from last time, right, where the deployment says, okay, we're taking a bunch of containers inside of pods, and the deployment brings the intelligence that says we can scale this up and down. If there's a failure somewhere, a hardware, or even a crash of some of our pods, the Kubernetes can self-heal the environment. So if, for example, we want 5 web server pods and something happens and it goes down to, let's say, 2, Kubernetes can fix it and get it back up to 5 without involving a human being. And deployments as well, we will come to them, like the kind of the foundation for like zero downtime rolling updates, and also the ability to roll back changes as well.
Thanks for the introduction. I think, yeah, pod, remember, pod is the basic execution unit in Kubernetes. So it's kind of the most important thing. And
I'll tell you what's good, Didier, actually, just real quick.
Yeah.
So if you think about VMware, the smallest unit of execution there is the virtual machine, the VM. Just in the Kubernetes world, the smallest unit of execution is the pod. So you could almost say they're analogous. In Kubernetes, you work with pods. In VMware, you work with virtual machines.
Yeah, okay. So in this lab, the first thing we do is we basically get our cluster, we connect again and get our credentials. And then we create a deployment. And if you look at this command, you see that what is a deployment? There are lots of options, but what we do here is we say we want to run a new deployment, and the image that we'd like to run, so this is a Docker image actually, is Kubernetes Bootcamp v1. And so we create one of these. It's very quick, as you can see. And then we can say, okay, show me all the deployments. So this is showing your deployment. I put a grep here to only see yours, but this is a cell. And the cool thing about a cell is it's editable. So you can go and remove that if you want and run it again. We should see a lot of students running the lab in parallel right now. And what you see here as the top of the columns is important because it says how many are already started against how many you have in your desired state. And we'll come back to this later on in lab 4 and 5. How many are up to date, how many are available, and so on. So this is for getting deployments. The next thing is what we want to do is look at, as Nigel said, we created pods for this deployment. So at least one. So if we look here, we can see that we are getting the name of the pod, and don't worry about this ugly line here. It's just a way for me to extract through a script the name of the pod from the command get pod. And then what I'm doing here is I'm executing against that pod. Very similarly, if you're familiar with Docker, the way to what you do when you do Docker exec, you're executing a command against the Docker container. Here we are executing a command against the pod. And the command we do is a curl HTTP localhost. So we are basically calling the website locally. And what we see is the application is already it's a basic application. All it does is respond, hello, and I'm running on, this is the pod name. So it's showing the pod name you're running on. And this is important when we do the scale up, because then it will be scaled across multiple pods. And then it tells you the version number. And as we remember, we used an image which was called V1. So this is V1 that we're running. This is important to remember when we do the rolling upgrade. This is interesting, but this is not very convenient because the application is running in a pod, but no one can get to it. So one way to actually show that we can get to it is through a simple construct that you can do, which is called a post-port forward. And if you Control-C this piece, and you open something called terminal here. So this is a terminal on the local machine, and you paste that. You're basically opening up a port forward. So whatever you're sending to 8080 is going to go to the container in the pod. And if we go back to this, now we can say curl against localhost, our machine, to see the same response from the website. Okay, so that's okay. That's one way to get to the pod.
Short question. Could you show how you open the terminal?
Yeah, I can show that again.
Thank you.
You go to plus, it says new launcher. And at the bottom here, you have a terminal.
Thank you.
All right, no problem. So let's move to this is one way to get to the pod, but you understand that this is not very convenient. We have to open a port forward, and what we need is a better way to expose our pod to the external world. Before we do that, let's talk about how pods can be made of. We said a container, one or more container. You see here 4 examples of pods with multiple containers, but they also contain storage, persistent storage for those containers, and they are assigned a private IP address. Okay, so that's kind of, think about a pod as an IP plus one or more container, which basically define an execution unit.
Didier, can I just really want to point out that although we are showing some pods there with multiple containers in them, if we scale an application up, we add more pods. We don't add more containers to that pod. The use case usually for multiple containers inside of a pod is if you have two different parts of an application that need to be tightly coupled. So maybe always scheduled to the same worker node, or maybe they share information over a local named pipe or something like that. I just wanted to be clear on that, and we'll see it later when we scale the application. We'll get more pods instead of getting more containers in a single pod.
Yeah. But so in this little lab here, it's pretty short. We do a couple of commands, kubectl command that will help you to troubleshoot your environment. Mostly logs, describe, and exec, which we used in the previous one. So let's get started with that. First of all, we get our pods, and again, you can remove that piece if you want to see all the pods, if you want to. And then we can say, you can use the command describe. Actually, describe works with a lot of elements or items in kubectl or in Kubernetes. You can do with pods, you can do with service, and so on. So here we're going to run a describe command on the pods, and you see a lot of details here, and jump in, Nigel, if you want. But the thing I want to highlight is, for example, the image that you're running, also the IP address of that pod. And I think that's all I wanted to show. And importantly, as well, is kind of the latest event that happened against that pod. So you can see that he pulled an image, that he created the container, and he assigned the container to a given worker. So we know it's running on worker 24, which is one of our nodes. So you get a fair amount of information from a describe. So that's kind of a very handy command. Well, I'll skip that piece because it's just to show another way to get to the service. You can run it, but it's I think it's a little confusing because it uses the API instead of using the URL to the website. But just ignore it for now. Another way to find information about your pod is to use the command logs, and this will show you the log from the application on that pod, and you get a lot of information when things go wrong from that logs command. We already used exec, if you remember, in previous lab to run the curl command, but here you could say, give me the environment variable for this particular pod, or give me the source code of the server.js if you make sure that you're running the right code. And you can see actually that we have the response that we see when we call the curl command against the website. All right, so you can go back to the terminal and Control-C this to stop it, because we have a better way to expose the service in the next lab, and I don't want this to interact with that. So let's jump to the next module, which is really about the service. Do you want to say a little bit about the service?
Yeah.
And how we use labels in this lab?
Yeah, sure. So I think we've talked a little bit about scaling applications up and down, and we said that by, when we scale an application up, we add more pods, and Didier said that each pod has its own IP address. So it kind of presents a challenge, like if you are consuming the application that we've got deployed here, yeah, and later on down the line, we scale it so that we've got, let's just say 5 instances of it. But then later on, that might scale down to 2 instances. How does your application that's consuming it know which of those instances are live and which ones it should make a connection to? And the idea is that, we don't want you to code that kind of logic into your applications. That's just not a good way of doing it. So what Kubernetes does is in front of like potentially multiple pods, it puts an abstraction layer, or it puts something called a service, which we're about to see here. And all that is a stable networking endpoint that you can hit, or your applications can hit. And the service is intelligent enough to know which pods behind it are up and running and alive. And the way that it does that is, so the service itself is that stable networking endpoint. And the way that a service knows which pods to forward traffic to is just by a combination of labels. So we may see it here where our pods have some labels assigned to them. And then when we deploy the service here, we say, hey, when you receive traffic, forward it on or round robin it across any pods on your cluster that have this particular set of labels. But the important thing is that a service is just a stable networking endpoint for a set of pods, and Kubernetes guarantees that as long as that service is up and running, so as long as you don't delete it, the IP address of the service will never change, and the name of the service will get, maybe we're going a bit too deep here, but we'll get registered with the Kubernetes cluster's DNS and things like that, so you can reach it by name, and that name will also never change. So the service never changes, even though pods below it or behind it can come and go. That service is your stable endpoint to hit.
Yeah, we'll do that in the coming lab. So let's create one of these services, as Nigel said, as a kind of a layer, a small layer or an artifact on top of pods. And the way we do that, again, we run that command here to get in context again. And we create a service. We list our service first, and you'll see that it returns nothing for that student ID. That's myself. And if I just want to remove that just real quick, I probably see, okay, so nobody has really moved ahead and created the service, so that's good. If we now expose our application, and there are multiple types, this is explained here. We'll use the node port, but you can read about the other options. And we create a new service of type node port, and we'll expose port 8080. So we run that command, and then we do a get service again for that particular user, and we see that our service is there, and it's been assigned an IP address. And if we describe, we get more details about that. We see the IP, we see the port that is being forwarded, and so on, what type of service, what type of networking it uses, and so on.
Just really quick, Didier. So sure. The line above where you've highlighted the selector line, that is the list. Well, it's only one actually, but that can be a list of labels that have to match the pods that we've deployed. And that's how this service knows to send traffic to the pod that we have on the cluster, because the pod has that label that it's selecting on there.
Yeah, thanks. For now, it's not so impressive because we have only one pod, but when we'll scale to 4, there will be 4 pods with that selector assigned, so that the cluster would know which pod to send the traffic to. We can run that for getting the node port and node name. So this is just a way to retrieve the port and one of the worker, or the worker on which this pod is being assigned. So now we can run a curl command to the web application by node name port number, which you would typically do as a client. And we see the pod name, the version, and the hello Kubernetes bootcamp thing. Here, if you look, when we did the describe, we see the labels. And as Nigel was saying, we have a label that says, that names the application. But we can add, or first of all, you can add the -L for label to almost any commands to filter by label. So that's quite convenient when running on a large cluster with a lot of things. For example, if we run this here, we only list things that have been tagged or labeled with Kubernetes bootcamp myID. Same thing for services. So you can get the pod, get the service, and you can add your own label if you need to add your own label. So here, for example, we decided that we wanted to keep a label for the version. So we add a label. We label the pod with a new. So a label is just a key pair. A value is a key, and the key and the value is separated by the equal sign. So if we run that, it just tells you that the label has been the pod has been labeled. And if we run a describe command again, we see that we have one additional label for version equal v1, which we just did. All right. And then we can do a get pods. Of course, there's still one, but get pods with that version. That could be important because later on we will try to upgrade the cluster to a newer version. So let's move to module 5, and this is where we are going to scale. And I think maybe you can say something about the replica set, which is an important construct.
Okay, sure. So far we've seen, well, I think it's fair to say we've seen pods and we've seen nodes. So pods host our containers that have our application code in, and they execute on nodes. And we've talked about wrapping that in an object called a deployment that lets us scale, and Kubernetes do self-healing and stuff like that. And we, generally speaking, will work directly with deployments most of the time. However, behind the scenes, Kubernetes has another object called a replica set that handles scaling operations and things like that. It's pretty much hidden from us as users. Kind of without getting too technical, the deployment object gives us a way to configure the replica set without actually touching the replica set. So all of the fields that are in a replica set that control the number of replicas of a particular application are out there. We configure those through the deployment, and we'll probably see it. I don't know. Yes. We don't use any YAML files here, but I think when we do the describe, it will probably become a little bit clearer, Didier, I think.
Yeah. We don't use YAML, but you could do it with YAML files as well. So let me show you that. So let's do a get deployment to go back into context here. And you remember we've seen that if you remove that piece, you've seen that we had this ready up to date available. And remember, ready shows how many you have in your desired states. So far, we requested one, we got one, and it's available and ready. But let's change that. To expose a replica set first, we can take a look at the object replica set rs. So if you do a get, you see that we have a get rs replica set. Again, you can remove that to see the full headers. So that's another way to look at it. And this is named automatically when you create a deployment. You don't have to do anything. And the command in kubectl to change the scaling is called scale. And you would just say, I want to scale, and I want a new number of replica to be not just 1, but 4. So let's do that. And if you do a get deployment here, and this is where it would be useful to do a control enter, because you can then run multiple times without changing. And you see my counter goes to 12, 13. And now it's already scaled to 4 out of 4 that we requested. So let me just run that. So I see other people plus deployment here. We can see that most people are running together with me, and they are up to 4 as well. Another thing you can do is you can run this wide command. Let me get rid of that. So you can see each pod and what let me put it back here, and on which node they're actually running. So you see that the 4 pods are split across the 4 worker node, and the 4 nodes, sorry, and they're all running right now. And we have, of course, 2 running on worker 24 because we requested 4, and we have 3 nodes. We can go into more details. As I said, describe gets you probably more than what you want, but you can see all the replica information here exposed in the deployment. The next thing is you can take a look at, if you remember, we run this command before in this lab, I think, and it showed only one IP address here, if you remember the endpoints. But if you look at in this one now, you see that we have more than one IP address because we have 4 possible endpoints for that particular service, if you want. Okay, so that's the 4 pods that are running the same application for load balancing. So the effect of that is, if you remember, we did that to get the node and the port. If you run this using control enter, you will see that the pod name, which is represented here, will change every time you run because you're hitting a different node, different pod, sorry, every time you run that command. Okay, it should do the same for you. All right, how are we doing on time? So we are a little bit short on time. So there was an option I added here in the lab just to give you a quick view on the Ezmeral container platform GUI, because if you have it, then you might be using the GUI as well. You don't have to do everything with kubectl. You can take a look yourself real quick. Basically, you would have to log in with your oh, wow. Sorry about that. I don't know what's wrong with that. Let me try again. Maybe this is not possible today. Something is wrong here. So let's skip that. But basically, you would log in with your username and your password the same as you logged into Jupyter Hub. And you can take a look at some of the monitoring of usage of CPU, memory, and so on. We'll check what's wrong today with that piece. The next step we want to do is we'll delete that service, and we'll double check that, okay, we delete the service, but that doesn't break, so we don't have a service anymore for that user, but your application still exists. Of course, you cannot connect to node name, port name, because you deleted the service. But if you went straight to your port name and did an exec, the application is still there. It's not exposed anymore through the service that we deleted.
Hey, Didier, just very quickly, wanted to just point out that although the scaling operation that we did there was a manual one where you went in and you changed the number of replicas from 1 to 4, Kubernetes does have auto scalers that will do it based on demand and things like that. These are just obviously beyond the scope of what we're doing right now.
Okay, and thanks, Christopher. He's telling me that it worked okay for him to go to the GUI, so I don't know what's wrong with my machine. Never mind. So the last important module here is we want to do a rolling upgrade, and I think most of you probably know what it means, but basically you want to one by one upgrade your pods to a newer version of your application. And the way you do that is there's a very nice way to do that with Kubernetes, and we're going to do it together. So let's get again in context. We have our deployment. We take a look at our pods, and we see that we have 4 because we scaled up the application, the service earlier. We describe that to get more details, and this is just to remember that we're running that image, remember? And this is the important piece here. And now what you can do is in your deployment, you are going to replace the image by a new image. This is actually, if you look, it's a completely different image name. We call it V2, and it's not even coming from the same place, but we run that, and this will automatically replace or attempt to replace the image in all running pods of that deployment. So if we do a control enter on this one, we'll see things happening here as we do that, because it's taking each pod one by one, terminating it and updating the image, then starting it. And we see that after a little while, we have the old pods, which are now terminated, and 4 new pods, which were started. If we look at a describe and look specifically on the image that we are running, we see that we are now running this new image. And if you look at a little bit of the details of what happened in the events, you see that it's been scaled down to the cluster, then up again with the new image. All right. Then we can expose the application again, and we can get the node port and node name, so we can call our application again to see that, okay, we have upgraded the entire application on our cluster to V2. The next command here is that mighty command that hangs. So remember, if you run that, it's for some reason it gives the result, but I don't know why. I couldn't figure it out. It doesn't return. I think it's just a problem with Jupyter Notebook here. And it says it's still running with that little star here. So what you want to do is go and press the stop button here, and you're good. Otherwise, you won't be able to run another cell while one is is running already. And we can describe that again. I've lost what I wanted to do here. I think, yeah, this gives you information about each of the pods, what happened, and you can see that they successfully, each of them successfully pulled the new image and started the container and assigned it to a pod, to a node. It's important, Didier, as well, that these are 4 new pods, so 4 new IP addresses, but because you have the service object sitting in front of them, abstracting that, then your application that consumes it doesn't care. It just hits the service, doesn't care what's behind it. So you performed the rolling upgrade and everything went well. However, it could be that there is a problem with that new application you're running out. And this is what we are doing in the next step here. We are trying to set an image, so change the image again with version 10. And version 10 here doesn't exist, basically. So it could be that it doesn't exist, but it could also be that there is a problem with your new version of the application. So let's run that. And immediately after that, we go and check again the deployment, use Control-Enter to see that, okay, it stays at 3 out of 4. There must be a problem because it should be 4 out of 4 by now. So we can do a get pods to see what's wrong. And we can see, we get an idea here because it says it terminated one pod. Then it tried to create a new pod, pulling the new image. And we see that we have a error image pull back off. So we can take a more closer look using describe. Now you know about this command now. And we will see that, oh, there's a problem. This image here failed to pull the image. Doesn't exist, basically, or there's a problem. So there's definitely a problem with that upgrade. So it's not going to try or attempt another update of another pod because this one failed. So the next thing that you will be able to do here is to roll out and undo the deployment. So we can do that together. And we roll back. And if we look again, we see that we, if we wait just a little bit, we're back to 4 nodes after a little while, running version 2. If we describe here, we are back to version 2 for everything. So each pod will have a version 2 image right here. Okay. That's it for the hands-on. We can then delete our service and clean up the thing and return to the main notebook. We have just a quick conclusion here. How are we doing on time? Yeah, 4 minutes to go. Perfect. So we have a survey which we'd like you to fill up to give us feedback on the tool, the content, the form, and the tool like Jupyter. Did you like it? Did you not like it? Which topic you'd like us to cover in addition to the 20 workshops that we have right now. And it's always useful to get feedback from people that have used it. Remember, this is available 24/7. I used it together with you, but you can go back and do that maybe on an evening or some time you set aside for learning. And we have other, as I said, other workshops. You can use, I'm talking for HPE people, you can use that to teach your partners, walk through with your customers. This is available on internet, so anyone can get to it. Don't forget the survey. This is very important for us. We had a couple of questions we wanted to ask, and let me just find it. We had a quick poll here that we wanted to launch for asking, how did you plan to learn Kubernetes? I think it's interesting to get your feedback on this. And another point, how you think you're going to consume Kubernetes. As you know, there's a lot of ways you can get a platform. You can build it in the cloud. You can build it on premises. You can even use your own, or you can ask HPE to build one for you, for sure. So let us know what your feedback is on those 2 questions. And then do you want to add something, Nigel, and wrap up on your side?
Not really, just to say thanks to everybody, really. Of course, to you, Didier, as well, for running the workshop. But I think once we got going with the questions and things, it was a great audience. It's really hard, isn't it, when like we could probably spend all day running an intro to Kubernetes, couldn't we? And some of the questions we're getting towards the end are just a little bit beyond what we have time and the scope to do right now. But just so that people know, all that we've done today, or we've tried to do, is like scratch the surface for you. Of course, it's incredibly more powerful than what we can show in such a short period of time. But just thanks to everybody.
Thank you, Nigel. So I'm just quite proud to say that we have never really run a workshop with that many people on that platform yet. So that's also a good test for Patrick and the guys. We had 42 people running that particular workshop out of the 51 seats that were available. So that's good. Thank you for answering that poll. And I'd like to run just the end of poll for you to Let us know if you like this session, if you want more of these, if you think the technical level was right, and if you would recommend that type of session to your friends, colleague, family, pets, all sorts of things. This booking was made for 4 hours.
I think my wiener dog would really like to take this class. You said pets. I can have my pets on this. Okay.
Give it a try. Thanks,
All right.
Don, for your help. People remember that the platform you booked is booked for 4 hours. So you can go back to the beginning. And if some of the pieces were too quick, you can do it again. And remember, these cells are editable. So you can, of course, don't break everything, but you can go and remove some of the, or you can do, for example, -- help to get the full detail about a particular command. Because in my lab, we only explore a couple of options, and there are sometimes more than 50 options in a given command. So you want to explore what are the options. Of course, you want to be gentle and not do anything terrible to the platform. With that, I would like to thank everyone, and to maybe have you come and join us next month for another Munch and Learn. Invite your customers if you want. This is available for everyone to join. External audience is more than welcome. So feel free to invite. Thank you very much, everyone. Thank you, Nigel. Thank you, Don and Patrick in the back with the platform here.